Hi, everyone. On behalf of the Florida Concrete and Products Association, thank you for joining us today for the presentation about Portland limestone cement. There is a chat function on your control panel on the right-hand side with a little bar that you can type in questions. Feel free to ask questions as we present. We will have a Q&A session at the end of the presentation, so let's get started. This presentation has been adapted from the Portland Cement Associations. The PCA is the National Trade Association for cement manufacturers in the United States and represents the vast majority of manufacturers in the US. The PCA is charged to improve and expand the use of Portland cement and concrete. For those that are not familiar with cement, it is the powder that is the primary binder in concrete and makes it get hard. Concrete is the finished product we see, such as a foundation, road, sidewalk, etc. This presentation will be conducted in accordance with SCMs antitrust policy. Thus, as stated here, there will be no discussions regarding pricing, terms, cost, plans, bidding, customers, etc. If you have any questions or concerns, please let us know. This presentation is brought to you by the Florida Concrete and Products Association and Florida's cement manufacturers, Argos, Ash Grove, Cemex, and Titan. Your presenters today are myself, Justin Fleming from Ash Grove, and Byron Velasquez from Argos. We are both members of the PCA and the FCNPA and have cement plants in Florida and other parts of the United States. These are the topics we will cover today. This is a product that can be used anywhere for type 1 or 1-2 Portland cement, namely 1-2 here in Florida, and is produced by all manufacturers in Florida. This is a non-proprietary informational presentation to prepare you for the future, as this product will eventually replace type 1 and type 1-2 Portland cement in bulk and packaged form. A PLC, or Portland limestone cement, is a blended cement with limestone as the non-Portland component. This cement is common in Europe and countries around the world. In the US, PLCs are a common cement type containing 5 to 15% limestone. This product provides a means of implementing proven technology to obtain desired performance and an option to improve the sustainability of cement and concrete. You might hear these products called different things by different groups. Type 1L is produced here in Florida. These designations are in the standards C595 and M240. The percentage of limestone given is in parentheses. The nomenclature provides a complete transparency for producers and users. So, what is a Portland limestone cement? Portland limestone cement is made by intergrinding regular clinker with up to 15% limestone, while regular Portland cement contains up to 5% limestone. Portland limestone cement is also ground finer than regular Portland cement. PLCs provide similar performance to Portland cement, but with a reduced environmental impact. Since the 1970s, improvements to US cement manufacturing have resulted in more than a 40% decrease in production energy. CO2 from cement manufacturing has two components: combustion/grinding, which is using natural gas and coal to heat a kiln to 2,700 degrees Fahrenheit, and electrical power to turn a finish mill. This heat is used for the second component, calcining, which is breaking down chemical bonds of limestone, calcium carbonate, into lime, calcium oxide, and carbon dioxide. Lime is a key ingredient in cement manufacturing. PLC represents an opportunity to further reduce the carbon footprint and greenhouse gas of cement. The opportunity with PLC is to reduce the CO2 resulting from calcination or breaking the chemical bonds of limestone. CO2 emissions are about 10% lower for the manufacture of Portland limestone cements versus ordinary Portland cements. This is a busy slide. Materials to the upper right have a higher embodied energy and CO2. Notice that concrete and cement are toward the lower left. When compared to a wide range of other materials, cement and concrete have relatively low embodied energy and embodied CO2 content on a mass basis, even compared to wood and other materials. More concrete is used annually than any other man-made material by a factor of about 10. Concrete is the most consumed material on Earth, second only to water. Thus, it is important to look for improvements in concrete sustainability. Something like 50% of all man-made materials are concrete by mass, and therefore accounting for 5 to 7% of the world's CO2 production is really efficient. The corollary of this is that anything we replace with concrete will likely drive up overall emissions and energy usage, even if we had the volume of materials to replace concrete, which we don't. Some of PLC's benefits in ready-mix concrete. Again, you get equivalent strengths compared to a traditional type 1-2 Portland cement. You also get improved finishing and pumpability, and it contributes to the environmental footprint. Very similar for block and pavers, equivalent streaks when compared to type 1-2 Portland cement. Also reduced efflorescence, and again, you're contributing to the environmental footprint of the structures with a green solution. Byron, over to you.
Okay, thank you, Justin. Appreciate that. This is Byron Velasquez with Argos USA, and we'll start with a brief history of PLCs. Okay, so come to find out that the PLC technology is not that new after all. They've been used around the world since 1965, especially in Europe, in Germany, where they've been very successful with using 20% limestone in their concrete, and they've used the limestone in multiple environments, either aggressive or just non-aggressive environments. So, which is a good thing. It's a good thing that we have that information, because we know and understand that limestones are underground limestones are very good for cement, right? So here in the United States, in 2004, the ASTM 150 allowing the limestone to be underground with clinker at a rate of 5% maximum. The AASHTO M85, which is a harmonized specification, also allows 5% limestone in the cement at this point, right? In 2008, the Canadian Standard Association includes the PLCs with a maximum of 15% limestone. A lot of research, a lot of development, a lot of testing was performed for many, many years in order to make sure that we have an equivalent PLC performance to the OPC. In the United States, because our construction industry is a little bit more conservative, or maybe a lot more, some people may say, especially the cement industry, in 2012, the ASTM 595 now allows a maximum of 15% limestone in the cement from 5 to 15%. It's kind of mimicking a little bit what the Canadian Standard Association has done, and it has worked very well for them, and it's working very well for us. The AASHTO M240 is a harmonized specification also that is important to know. As stated, in Europe, the PLC have an excellent track record. It's been used for many, many years. They go a little bit further though on with the limestone as far as content. In some applications, probably not for structural, they allow 35% limestone content in their cement. But overall, the most popular cement in Europe contain up to 20% underground limestone. Here in the United States, the PLCs have been growing in popularity since from 2012 to 2016. 2.5 million metric tons of PLCs have been produced and used. It seems a little bit low compared to the OPC in this moment. In the United States, there's a consumption of about 90 million metric ton of cement being used now, but the PLCs are catching up very, very rapidly, and we'll see why. The cement manufacturers have placed a great effort, have made great strides working with the state highway agencies towards the acceptance of a Type 1L. And as you can see on this map, this is where the Portland limestone cement is accepted, by the state, on DOT projects. There's a lot of green. Like I said, the PCA has done great efforts in that. The darker green is where the Portland limestone cements are accepted. Lighter green is planning to accept, and the yellow one is considering. In Georgia, we're working very hard to get that state approved. So testing have been performed, and a bridge deck has been poured and is being analyzed in this moment. I believe hopefully next year we'll have an acceptance in that state also. As far as California goes, we understand that they're very carbon dioxide conscientious, the greenhouse gases. So we should see California here hopefully next year also be on the green side. So there's an improvement day by day, and every year in this map, so which is good. So if you have a project in Florida, or maybe you want to go to Pennsylvania or somewhere else, then the Portland limestone cement are accepted. As far as the agencies, the DOTs, specifically with the Florida Department of Transportation, in January 2017, they added the Type 1L cement in their specifications. However, there's a plethora of testing that has to be performed in order for the cement to be approved by the FDOT. On the cement, an XRF analysis, the chemical analysis and physical testing has to be performed and provided to the FDOT without the reporting requirements, heat of hydration as well. And also on the concrete, there's a plethora of testing that must be performed and must comply with the specification in order to have the cement approved by them, like surface resistivity, the compressive strength, chloride diffusion, sulfate resistance, and so on. So once those testing are reporting to the agency and they approve it, then the FDOT issues a material bulletin where you can substitute a Type 1-2 cement for a Type 1L on the governmental projects. Other approvals, this is important. The American Institute of Architects, the master spec. And the reason why it's important is because there's a lot of private projects that use this specification, and if they have the poured limestone cement in it, then ready-mix manufacturers will be able to use the PLCs in their mixes. The ACI, American Concrete Institute, as well, the 318 and 301, allows the use of Portland limestone cement. The International Building Code makes reference to the ACI 318, and the FAA, Federal Aviation Administration, makes references of PLCs in the P501. This is just a reminder to tell you that the ASTM C150 is what the specifiers recognize the most, the engineers and architects. And if you can see on the bullet point, we already use up to 5% limestone biomass in the cement. So we already have a history of using limestone here in the United States, which is very, very good. And that will allow us to take it to the next level and train or educate the specifiers in the fact that this will be the specification of the future. It is right now being implemented in many projects. The ASTM 595, which allows for an amount of limestone, underground limestone, from 5 to 15% by mass. This is very important because we have a sustainable movement in the United States and throughout the world, where we need to reduce the carbon emissions, and it allows for an equal product by producing the PLCs, and we'll see that there's even more than that in the next few slides. So how does limestone work exactly? I mean, because limestone, understanding that it's an inert material, so there's different mechanisms. One in particular is the particle packing. So we understand that the clinker and the limestone is underground right at the same time. So the limestone being a softer material than clinker, then you'll have more of fine particles. Those fine particles will find their way into the voids in between the clinker particles, meaning that you will have more dense material and denser concrete at the end of the day. So particle packing would be one of the big mechanisms here that we bank on the PLCs. In addition to that, because there's more surface area for the limestone or for silicates to grow on the limestone particles, so there's a promotion of nucleation, meaning that the silicates will form on the particle, and the CSH, the calcium silicate hydrate, which is the basic of the glue in the paste. That's what you want. You want some CSH to be formed. The limestone allows the formation of those silicate to promote strength. Again, limestone is a inert material, which meaning that they don't create much chemical reaction or not, very small amounts. But this may be due to the fineness of the material. Let's move on to performance of fresh and hardened concrete. As stated, the fineness in the cement counts for a lot. It will influence the properties like workability, compressive strength, shrinkage, and durability. As far as the durability goes, it's an extremely important item for the DOTs, especially for them, governmental projects. The ACI 318 specifies durability requirements as external sulfate attack, whether it's from your soils, seawater, wastewater. That can be mitigated with SCMs, the chloride ingress, and the freeze-thaw cycle. So those items are tested and were tested in the past, and the PLCs meet the requirements of all those items in the durability. As far as fresh concrete properties, the workability increases, the pumpability also. We've seen some improvement in the pumpability of the concrete. Bleeding decreases, that's due to the higher surface area of the particles. Set times are pretty much equal. Heat of hydration slightly increases, but again, I mean, that can be mitigated with any type of SCM, especially slag. As far as performance, Dr. Michael Thomas from the University of New Brunswick and Dr. Doug Hooton from the University of Toronto made a lot of testing for many years, and they came to the conclusion, in fact, that with all the testing, the durability on strength and permeability and everything, that the PLCs react pretty much in an equivalent form to the OPCs. You know, when you air ground the limestone all the way up to 15%. This is excellent news because again, I mean, the sustainability of our buildings, of our structures are very important, and the PLC counts a lot for that. So in this case, at early ages, you'll have an equivalent performance as far as strength goes, and at later ages also in 56 and 90 days as well. As far as permeability, the chlorides under the ASTM C1202, Michael Thomas from the University of New Brunswick also made an enormous amount of research and concluded that whether it's without any SCMs or with SCMs, we can see an equivalent performance of the PLCs versus the OPCs. The interaction with supplementary cementitious material, like what? Like slag, class T fly ash, class F fly ash, silica fumes, even in the future, ground glass or some other ones. Portland limestone cement have an affinity for SCMs, and the reason why is that there's something called the calcium carboaluminates that provide a modified hydration during the strength formation, and that provides even an added durability when the water cement ratio is optimized in your mix designs, and it also provides increased strength at longer periods. The SCMs are very important because it adds even more sustainability to the mix designs when the slags and the fly ash are dumped in the in ponds and landfills. We can use them in the concrete and even increase the sustainability of our concrete, right, and of our building, of our structures. All right, let's move on to example projects. What we want to convey here is that the Portland limestone cements have been used in all kinds of environments, whether it's the harsh conditions in the Canadian winters, like this project, 14,000 cubic yards, multiple mixes using SEC technology and using Portland limestone cement. They've been very successful on it. Even in Colorado, using 75% Portland limestone cement and 25% fly ash. Very beautiful project, very good. Utah also, in all kinds of climates, the Portland limestone cement have been used, and it helps reduce the carbon emissions, and it has the durability that we are looking for. This is closer to home now. In Tampa Bay, here in Florida, the Virage condominiums, pretty important high-profile project, 18,000 cubic yards, straight cement mixes with type 1L cement, and even with slag 50-50 mixes and very successful project, very high profile. This is an ongoing project, and even you can drive by it. They're using Portland limestone cement at a rate of 30% and 70% as slag mixes. These mixes, these concrete mixes, they use it that way, is to mitigate the heat of hydration of the concrete, because there's a lot of mass concrete in this project, and some other structures as well. It's pretty interesting project. St. Pete Pier, another high-profile project where Portland limestone cement was used in multiple applications like piles, drill shafts, and bridge decks. 50% slag was used in conjunction with Type 1L in these projects, and this was done. It's finished, and you can visit it. Also, a very nice project. Florida Precaster also, this is a precaster that's using 70% of Type 1L and 30% of Type 3. This application, they want to have it to have an improved aesthetic, better finishability, nicer surface, and easier to finish, right? And again, SEC technology mix. Another high-profile project, we're using Portland limestone cement in Daytona Beach. Over 75,000 cubic yards of concrete was poured with all kinds of mixes ranging from 2,500 PSI to 14,000 PSI. So very nice project, very high profile, and they've had great success on it. This is an ongoing project that you can drive through it. The Gateway Expressway, this is a massive project anyways, $596 million. And Portland limestone cement was used, or is being used, with all kinds of SCMs on this project, and it's going very well. Actually, you can go on the FDOT website and take a look at the improvement and advancement on this project. Oh, Justin, okay, that's yours. I'll give you the floor now.
Thanks, Byron. So this project is the cabin at April Farms. This was done by the Conlin Company and was over 390,000 square feet using 15,000 cubic yards of concrete. The site was originally the last active dairy farm in Hillsborough County. This was a tilt-up construction project. So as Byron discussed, you can use Type 1L cement in a variety of applications. Next is School Triple T. This might have a name by now, but as of the time of the project, it was unnamed or codenamed. This is in Riverview, Florida, just south of Tampa. Core Construction teamed up with the concrete finisher VMG, and this is going to be a new high school. It's going to enroll about 3,000 students and covers more than 238,000 square feet at a cost of $70 million. Again, this was a tilt-up job that was completed last summer. Let's look at a few bridge decks. And everybody will get a copy of the deck after this presentation. And if you want to go explore a little bit, you can use the Google Maps link at the bottom of the slide. This one's in Taylor County, done by Anderson, Columbia. And this was a bridge replacement over Cypress Creek. Another bridge deck in Gadsden County, Havana, Florida. And this was a replacement on County Road 159 over Attapogus Creek with Murphy Bridge construction. A few more in Jefferson County, Lloyd, Florida. 2 bridge decks on County Road 158 over Lloyd Creek. And some additional information from the PCA. As this technology has been common in Europe for several decades, there is a lot of technical literature available on a wide range of topics related to the use of limestone in cement. 2 recent reports are available. They are free to download at cement.org, which is the PCA's website, or if requested, we can send these to you after the presentation. Also, should be noted that PCA is developing a PLC website, and that should be ready at the end of the month. I'd like to thank everyone for joining us today, and we will now open the floor to some of the questions that you've been submitting throughout the presentation, or if you still have questions, feel free to submit them while we're doing the Q&A. And again, as a refresher, you can type in your questions in the chat box on the right-hand side of the control panel. Matt, do we have any questions coming in?
Well, we have our first question, and it is, will a copy of the presentation be available for downloading? And the answer to that is yes. We will have this both available. We'll put it on our website, fcpa.org, and then we will also make sure to send out a copy of it to any of our attendees today.
Excellent.
With that said, again, if you have any questions, now's your opportunity. If you go to the question box on the right-hand side, you can type it in, and we'll be more than happy to field those for you. Otherwise, we'll just assume that this was a flawless presentation by our 2 presenters.
Thank you, Matt. We appreciate that very much. And it looks like my yard guy is unloading, so we did it just in the nick of time.
Fantastic. Well, we don't have any more questions coming in that I see. So with that, I would say thank you for attending today. If for some reason, afterwards you have any questions, you can always contact the Florida Concrete and Products Association, or as you saw on the first slide, both of the contact informations for Justin and Byron are both available, and you can contact them. And with that, I do have one more question, actually. Do you have any information on uses of cement for pavement concrete?
I have some from a previous PCA presentation, and a lot of those were out west. I want to say Colorado, Utah, various states in the West and Midwest. But yes, it has been used extensively in mainline paving and even in residential local streets and roads paving. And from memory, same performance, same finishability, equivalent product.
Okay.
And I can get those to you, Matt, and you can distribute those as well if you'd like.
Okay. We'll make sure to include those with our send out. And he responded, thank you for the webinar. So it looks like that's all of our questions. So like I said, if you have any follow-up questions or something hits you later on in the day, feel free to reach out to us. We'd be more than happy to get those questions answered for you. And otherwise, we want to thank you for participating in today's webinar. We look forward to continuing to do more as we go here. So make sure to check back often at fcpa.org. And otherwise, everyone have a great day. Justin, Byron, thank you for your help today. We appreciate it.